Hi, chemistry students. This is your lesson on more mole calculations. You're going to need a calculator for this lesson and a periodic table. So if you don't have those available, please get them now before you start. In addition, it's going to be very important that you take notes. So please be sure that you put a heading, a title on your notes, and a date, more mole calculations, and whatever today's date is, so you are able to find these notes and understand what you're writing down. We're going to do examples that you're going to want to write. All right, so first of all, I want you to think about and look at your periodic table and ask yourself the question, are all atoms the same size and mass? And the answer to that, of course, is no. For example, if you look at the atomic mass of sulfur, it's 32 versus the atomic mass of hydrogen, which is 1. So you would have 32 atoms of hydrogen for every 1 atom of sulfur. And we do need to be able to count atoms in an efficient way in order to understand and make predictions for chemical reactions in later units. So how does this relate to a mole? So the atomic mass, which is here, for example, for carbon on the periodic table, which we've learned is the average atomic mass in atomic mass units for all the isotopes of carbon, is actually what's called the molar mass of that particular, or the atomic mass of that particular element. So what that means is 1 mole of carbon actually has a mass of 12.01 grams. All right, so the molar mass and the atomic mass of elements are the same. Whatever you see as the atomic mass on the periodic table will also be the mass of 6.02 times 10 to the 23rd atoms of that particular element. It's very convenient. So a mole of atoms of different elements will have different masses. Just like a dozen ping pong balls and a dozen bowling balls are still 12, still a dozen, but will weigh quite a bit differently. So a mole of an element is equal to the atomic mass in grams. That's probably the first thing you're going to want to write in your notes. 1 mole of an element equals the atomic mass in grams. You can also see that carbon, for example, has a molar mass of 12 grams. So that means 6.02 times 10 to the 23rd atoms of carbon weigh or have a mass of 12.011 grams. On the other hand, magnesium is a larger atom. So if we have 6.02 times 10 to the 23rd atoms of magnesium, they're going to weigh more. But you can actually see this is going to be very convenient for counting atoms, because instead of having to count 6.02 times 10 to the 23rd, if I want to make sure I have 6.02 times 10 to the 23rd, I just have to weigh out 12 grams of carbon. All right, so again, to reiterate, a mole of carbon would be 6.02 times 10 to the 23rd atoms, which would be very hard to count. We've learned that in previous lessons. But it would also be equal to 12.0111 grams. And that means to get a mole of atoms, I just need to go to a scale and weigh out 12 grams of carbon. And then I know I have this number of atoms of carbon. So, for example, a mole of aluminum, if you look on your periodic table, its molar mass, or its atomic mass, is 26.98154. That means that if I want to get 6.02 times 10 to the 23rd atoms of aluminum, I just need to go to my scale. Maybe I've got some aluminum can or aluminum foil, and I need to weigh out 26.98154 grams, and I know I have that many atoms. Now, why is that a larger weight than carbon? It's because aluminum atoms are bigger. Okay, how about a mole of gold? I want my 6.02 times 10 to the 23rd moles of gold. So I need to go look on my periodic table, and I will see that the atomic mass of gold is 196.967, which means if I go to my scale and weigh out 196.967, I can be pretty sure I've got 6.02 times 10 to the 23rd atoms. All right, now that's for elements. We also need to define the molar mass of a compound, because a lot of the things we work with, water, salt, are compounds. So you'll want to write this definition down as well. So maybe pause the video. And so the mass of 1 mole of atoms in a molecule added together from the values on the periodic table is the molar mass of the compound. Best way to sort of see this is for me to give you a a couple of examples. So be sure you have this written down. If you need to pause the video, do that. And then we're going to do a few examples. So here's how you would calculate the molar mass of a compound. For example, carbon dioxide gas has the formula of CO2. So one molecule of CO2 has one carbon and two oxygens in it. What if I want to know the weight, or I want to get 1 mole of carbon molecules, or 6.02 times 10 to the 23rd molecules of carbon dioxide? Well, I can go weigh it out. So we know from the periodic table, carbon has this atomic mass and oxygen has this atomic mass. But we also know we have 2 oxygens here. So we're just going to add the weight of the carbon. And notice I have rounded to the hundredths place. That's what we'd like you to do every single time. We don't want you to round any further than that. It's going to be important in terms of weighing things out that we don't want to be off by more than 1/100th if you make a mistake in your calculation. So we want to make sure we go out to the hundredths place. So 15.9994 rounds to 16. And therefore, we know, sometimes it's called the formula mass. The molar mass of this formula for this compound is 44.01 grams. And that means that 6.02 times 10 to the 23rd molecules has a mass of 44.01 grams. How about the molar mass of water? Okay, so again, it's just like we're weighing each individual part and adding it together. If we want to go out further, like to the, I believe that's like the 10,000ths place. Here's the molar mass of oxygen, the one oxygen in H2O. Here's the molar mass of the 2 hydrogens. We add them together, and this would be the overall molar mass of our H2O. And again, this unit just means 18.0153 grams per 1 mole. Okay, so a mole actually is 3 things. I'm going to introduce the third thing to you right now. We know it's a number. 6.02 times 10 to the 23rd, and that never changes, of particles. And the particles we usually use are these really little things called atoms or molecules, or occasionally you will see them called formula units. A weight, it's also a weight. It's the atomic mass on the periodic table. And it's also, when you have a gas at what's called standard temperature and pressure, STP, which is essentially 0 degrees Celsius and normal room pressure, the volume of that gas, remember liters is a unit of volume, is 22.4. So we essentially now have 3 conversion units, and we're just going to use dimensional analysis to go between those conversion units. Okay? So it's these 3 things. 1 mole equals 6.02 times 10 to the 23rd. 1 mole equals the atomic mass on the periodic table in grams. And 1 mole of a gas at standard temperature and pressure is 22.4 liters. Again, you can see this with gases. If I have 1 mole of gas, I'm going to have 22.4 liters of any of those gases, and their masses will just be the atomic masses, or in the case of the CO2, the formula's mass for that particular element. And this is calculated incorrectly. This should say CO, but this would be 44 grams. All right, so we have this thing called the mole road. And essentially, this is your way of sort of thinking about converting between all these units. We always go through a mole, and a mole is something that we do to make things sort of smaller, taking lots of particles and making them a smaller, more manageable number. So to get to a mole, we're going to divide by 6.2 times 10 to the 23rd. To go away from a mole, we're going to multiply by 6.02 times 10 to the 23rd. And it's the same with these other units. If we want to take a mole and change it into its mass, then we're going to multiply by its molar mass. If we have a mass and we want to know how many moles, then we're going to divide. Same thing with if we have volume of a gas. That number is 22.4. So if we have a certain number of moles and we want to know how many liters of gas we have, we multiply by 22.4. And if we have a number of liters of gas and we want to go back to moles, we're going to divide by 22.4. You can also see we can go between 2 units. It's 2-dimensional analysis units. So from particles to gas, like we have a certain number of particles of gas, and we want to know what volume that is. First thing we'll do is divide by 6.02 times 10 to the 23rd to get moles, and then we'll multiply by 22.4 to get volume. Best way to do this is to write down some examples. So let's do that. Okay, so first of all, let's convert moles to grams. Here's the first example. How many grams of lithium are in 3.50 moles of lithium? So we know our conversion unit is 1 mole of lithium is 6.941 grams. And again, we match things. We start with our T-chart, the thing that has the number, 3.50 moles. And then we're going to go to the how many, which is grams. And then we're going to arrange our conversion unit so that we cancel moles and are left with grams. So we'll cancel out moles, and that means we're just going to multiply. When it's side by side, it's multiply. When it's below, it's divide. So this is just going to be 3.5 times 6.94, and that will give you 2.43 grams. Okay, 3 sig figs. All right, let's do another one. How many moles of lithium are in 18.2 grams of lithium? So again, we know 1 mole of lithium is equal to the atomic mass in grams of lithium, which is 6.941. We got that from the periodic table. And we're going to set up our T-chart. Start with the number, which is grams. What are we going to? We're going to moles. And we want to think moles of lithium. So we know we're going to use our conversion factor and arrange it so that grams cancel. Now, since this is down below, that means we're going to do a division. And that means that we have 2.61 moles of lithium. And that makes sense. 1 mole of lithium is about 7. And we got more than 7. So it's got to be more than 1 mole. All right. Now, again, we can also calculate with standard molar volume. And again, that's just a number to remember, just like 6.02. It doesn't change. 1 mole of gas at this standard temperature and pressure occupies 22.4 liters. So let's use that one. How many moles of hydrogen are in 100 liters of hydrogen at STP? So again, our T-chart, we find the number and the unit. We find the how many, and we have moles. And now we know our conversion unit, which is 1 mole equals 22.4 liters, because that's always the way it is. And we put the liters below because we want to cancel units, which means it's a division. And again, remember, moles is always a way of getting a big thing and making it smaller. So that's always why it's a division. This is a lot bigger than 22.4. And again, where did I get that? That's just a number we have to learn. A mole of gas, standard molar volume, is always equal to 22.4 liters when the gas is at 0 degrees Celsius or 273 Kelvin and at normal atmospheric pressure. All right, now, we're going to do a two-step problem here. And again, we're going to go over this a lot more. This is just an introduction, but we're going to do a two-step problem here. It says, how many atoms of lithium are in 18.2 grams of lithium? Now I'm going to do something before, and I know this is taking us way back, but I want to just show you something. So we're going through this mole road here, and you'll see what we're going to do is we're going to go 2 steps, okay? So we're going to change mass to moles and then to particles, or we're going to change particles to moles and then to mass, or we can do particles to moles and then to volume. It's a 2-step problem. It's always going to be a division by whatever conversion unit you choose for a mole, and then it will be multiplication. And again, the units will be your guide. So let's go back to that last problem. Sorry for going so fast. All right, so how many atoms of lithium are in 18.2 grams of lithium? So we set the T-chart. We've got this. We know 1 mole equals 6.941 grams. We also know that 1 mole equals 6.02 times 10 to the 23rd atoms. So let's set up our T-chart. It's going to have 2 conversion factors. We always start with the number, 18.2 grams. We always go to the thing that's the how many. In this case, it's going to be atoms, but we're going to need 2 conversion factors leaving us with atoms. First thing we need to do is get rid of grams. So 1 mole equals 6.94 grams. That will get rid of grams. If we stop here, we're converting to moles, but we want to get to atoms. So then you do 6.02 times 10 to the 23rd atoms of lithium is 1 mole. And if we cancel units, you can see all that is left is atoms, okay? Now, I want to caution you. You should do this continuously in your calculator. You should not stop and round, all right? Scientists, that's the protocol. So even though you'll get an answer here for moles, don't re-put that in your calculator. Just put in 18.2 and it would be times 1, but we don't need to do that, divided by 6.94. And you can say equals, but then don't put it in your calculator again. Leave it in your calculator and then multiply that number in your calculator by 6.02 times 10 to the 23rd, and you will get the right answer. Since these are all 3 significant figures, you should round to 3 significant figures at the end, and that's going to be 1.58 times 10 to the 24th atoms of lithium. Now that makes sense. This is more than a mole. Okay, I mean 18.2 is more than a mole. A mole of lithium is only about 7. So we've got more than a mole. So we're going to have more than 6.02 times 10 to the 23rd because we have more than a mole. All right, well that is your lesson on mole calculations. We're going to do a lot more of this in class, so please be sure that you are looking at these examples, and we'll talk more about it in class.